Micturition. Micturition is the process of urinating. There is involuntary and voluntary control. With involuntary control, stretch receptors in the bladder walls are stimulated when the volume of urine in the bladder is 200 milliliters. Once the bladder walls are stimulated, sensory fibers in the pelvic nerve relay information to the sacral spinal cord. Motor fibers in the pelvic nerve and the parasympathetic ganglion in the bladder wall send outward signals from the spinal cord back to the bladder. This relaxes the internal urethral sphincter and the bladder is emptied. With voluntary control, feedback from stretch receptors travel up the spinal cord to the Micturition center, which is a nucleus located in the pons. The Micturition center works with other brain centers in regards to bladder tension. The amygdala and the cerebrum are examples of such brain centers. Micturition center fibers down the spinal cord through the reticulospinal tracts. These fibers will either inhibit sympathetic neurons or excite parasympathetic neurons. When the internal urethral sphincter is contracted, it allows the bladder to relax for urination to occur. The bladder will begin to empty once nerve fibers from the cerebral cortex travel down the corticospinal tracts and inhibit sacral somatic motor neurons that will typically keep the sphincter constricted. This is the factor that allows a person to stop urination midstream and have control of urination. Voluntary control matures as a child grows. If urination is inconvenient, the stretch receptors will send a signal to stop firing and allow for urination to cease. To put micturition in simple terms, stretch receptors in the bladder will send a signal to the sacral region of the spinal cord, and the spinal cord returns the signal and begins the relaxation of the internal urethral sphincter in order for the urination to begin. This reflex is voluntary control. Voluntary control over urination will mature as the child grows. Urination is controlled by the Micturition center in the pons. Signals can be sent to inhibit urination when the sphincter is closed, when urination is inconvenient. The spinal cord will send signals to the external sphincter when urination is able to occur, and the muscles of the bladder will relax.